Hey everybody, welcome back. As you can probably see by this nice chicken B-roll, I have chickens, and they are extremely noisy in the morning, and like really early in the morning. I'm talking like 6 a.m. Today it was 5:55. It woke me up and looked at the clock. And that's because they just really want outside, and they really want food, and they really want attention. And none of us, since we're city folks, we're not real farmers. We just have some pet chickens. None of us want to get up at 6 in the morning and let the chickens out. But they're so noisy that we had to do something about it. And this being a tech channel, I probably came up with the most overly complicated way possible to manage the chickens, and that's what I'm going to show you today. So I'm doing this while I'm editing this voiceover because, I mean, there's going to be chicken ambience in the background if I did this outside, and also I forgot to do it outside. So let's just say I did this on purpose, and enjoy the video. So here's the chicken contraption. This all started with this pre-bought thing here, Chicken Guard. It's designed to let out the chickens in the morning, because when they don't get what they want, they're very loud about it. And they always want out at like 6 in the morning, and they're super noisy and annoying, and nobody wants to get up at 6 in the morning. Oh no, there's some drama happening. So it all started with this. This is a pre-bought thing that you can buy, and it looks at light levels and time, and it lets them out and locks them in at night, and it's super useful. But it wasn't quite enough. They were still very, very loud in the morning, like really early, again, like 6 in the morning. This morning, I woke up at 5:55, and there were just chickens going absolutely crazy. I don't know why. So that's how it started. And then it was, well, okay, they're still not being quiet. They got out, but they're still super loud. Can we feed them too? So now there's automatic feeding that was put into this. And then the final thing was this guy. This guy runs on batteries or on a 5-volt phone charger. And I didn't like either of those because I'm super nervous about the chickens not getting put in at night and then getting eaten by raccoons. That's like my biggest fear. Why not just go all out is what I thought. So I have a battery backup for this thing. I have cooling fans, and I have an automatic chicken feeder all hooked together to make the ultimate, probably not yet, it's always changing, but pretty soon to be, if not already, the ultimate chicken automation system that I spent way too much time on. And yeah, it's all kind of in this box here, and I'll open that up in a minute. But we have, since it's a UPS, an uninterruptible power supply, it's the same kind that you'd get with like your modem, I think. I found it at Goodwill. Because it's a 12-volt one. It's not one that steps up 100 or 12 volts to 120 volts when it's on battery. It just switches over to a battery, which is nice because this only needs 5 volts. That only needs 5 volts, so it doesn't need the whole AC inverter part. So this is just the lights that were on the front of the UPS when it was inside of its normal enclosure, just brought out to the outside so I can see it. There's also an Arduino in here, and that's what that blue light's hooked up to. And I'll get to what it means in a minute. And then we also have computer fans that were demoted to chicken cooling. And inside, it's kind of hard to see. I'm going to have to open this up. Inside, we have a very broody chicken. She thinks she has babies to keep warm, but there are no eggs and no babies. And she's been doing this for like a month. So she'll be clucking while I'm in here, but she doesn't like when I'm in here. But there's a little transformer up there too. That provides power for the feeder and the fans, because the UPS doesn't actually supply that much power, and it's really only for the chicken doors. We want to make sure that gets the most power. And also in here we have the battery for the UPS. There's another view of the fans. Got one of those no-name super fan fans that I think are commonly used in Roseville server chassis. and these two Cooler Master fans. And then there's Ren, baby Ren. We'll get you some chicken noises. Yeah. Normally a broody chicken will peck the hell out of your hand, but she's super friendly, so it's fine. So, I'm gonna open this up and we can get a better idea on what's going on in there. So it's kind of a rat's nest, yeah. There's a lot of stuff in here. This went through many revisions, so there's a lot going on, but I'll just kind of walk you through everything that's here. So these two pre-made boards are part of the UPS that I took apart to put in here. This one, I mean, I can only assume because I didn't make these, but this looks like an AC power supply, which is why I'm not touching it. There's the high voltage in. I mean, it's a mess. It's probably violating some code, but there's 120 volts that goes up into the power supply here. The power supply then plugs into this board, which is the UPS board. The battery hooks in there next to that fuse. This camera really does not want to focus, so I'm sorry about that, but that's the battery in there. And this board controls, yeah, if the power goes out, this relay clicks over to battery. On this board we have the on-off switch, which I'm not going to turn off because that will kill power to the chicken door, but that turns it on and off. Up here I have this massive relay board. It's overkill for this, completely overkill, but I had it laying around, so I decided to use it. I mean, there's quite a few unused relays on here, and that's broken off. Okay. But yeah, the relay board, unfortunately, controls the lights too, which is really dumb and not how I would have done it normally, but again, I just wanted to get this thing finished, so I used the relay board to control the little tiny LED lights in the front, because those run on 12 volts, and this board only outputs, I think, 5 volts, or this chip, and I have these wires soldered right into the microcontroller on that board, and they go into the relay and into the lights. It's making some concerning noises for sure. So that's the UPS circuit, those two. And the power, this is the output from the UPS, what's always on, and it goes two places. One, it goes to the lights, goes into the relays, powering the lights. That's just 12 volts out of there. Then it also goes into this voltage regulator that gets very hot. That's a little custom circuit board. And that voltage regulator regulates the voltage to 5 volts, which gives power to the chicken door, and also gives power to the relay board because it's a 5-volt relay board. And it also gives power to the Arduino controller up there, which we'll get to in a minute. So then what else? This down here is the second power supply board, because even though this thing says it can output 3 amps, whenever the feeder goes off, which we're going to take a closer look at in a minute, it just goes into an overload state and turns off, even though it's just a little DC motor. So I just don't want to risk it, so this thing is only powering the critical stuff, and this powers the non-critical stuff, which has 2 regulators. This hooks into the transformer that we saw on the inside, and it has 2 regulators. It's got 12 volt, that is the 12 volt regulator, and a 5 volt regulator. The 5 volts goes over to the chicken feeder, and the 12 volts goes to these fans here, which you can turn on from a switch on the inside. And that's going to be very loud because my microphone's right there. Okay. And then, so the hardest part was actually syncing up the door with the feeder, which is a pre-made fertilizer spreader, and it's an electric fertilizer spreader. You can buy it on Amazon for like $17. I think it's kind of perfect for this. I'll show you it in a second. But what I ended up doing was, there are a lot of different things. I was like trying to get the door to trigger a transistor to activate the Arduino. I was trying to get it to trigger this relay switch. I mean, it kind of baffles me, this door. I could not figure it out. But I eventually realized that I was stupid, and the easiest thing I could have done was just hook the door motor directly into the Arduino and just said forget it to all the other stuff. And so that's what I did. This little tiny chunk of circuit board is my afterthought of a final design for getting the door hooked up. It's just a pull-down resistor, a 1 kilo ohm resistor, hooked into the door motor, which is what this little lever nut is connected to. That goes right to the door motor, and that goes into the Arduino. And what the Arduino does is it doesn't actually know when the door opens or closes. You'd think it would be able to detect the difference between a high signal and a low signal because it's a little brushed motor in here that the polarity when it closes gets reversed, because when you hook up a motor in reverse, the door will lower, and then in one way it'll open, and it's just a little brushed motor. But the for some reason there's like half a second of no matter what the door is doing, it's always a half a second of a positive signal, and that's enough that the Arduino can detect it. So what I have to do is I have the code set up, so you have to kind of get it in sync with the door, but once you have that, it'll just assume that the door is opening on one cycle and closing on the other cycle. When the door opens, it will wait 45 seconds. It'll wait 45 seconds, and this blue light on the front, it blinks whenever it detects something. So it'll blink when it notices that the door is opening, and then it will turn off and wait 45 seconds. And 45 seconds later, the feeder will turn on, which we are going to take a look at in a minute. And once the feeder turns on, it'll turn on for like 1.75 seconds, I think. Then it will turn off, and the light will also turn on with the feeder. It's just an indicator light to indicate things are happening. And then the light will turn solid, and the solid light means that it will not set off the feeder the next time the door is active, because it doesn't know the difference between opening and closing. So once the door is set to close, the blue light will be on. And once the door closes, it'll blink saying, okay, I recognize that the door is closing. And then it's going to wait 1 minute and then just turn off. And that means it's back to the beginning of the program, which is waiting for the door to open again and to set off the feeder. It's not complicated, although I think I explained it pretty poorly. But it's just pretty much just a timer, and one cycle it ignores the door, doesn't set off the feeder. But yeah, the relay, also one of these wires, controls that. So I'm going to put this back together, and then we can take a quick look at the feeder, and I guess we can activate everything just for fun. Alright, so here's the feeder. It's for anyone who wants to build something like this themselves. This is I think the brand is Scott's, and it's called a Whiz, not my name. But it's the Scott's Whiz. It's an electric fertilizer spreader. So instead of having to crank it by hand, it's got a little motor in there. But yeah, all it has on here is a 12-volt input, and a switch to turn it off, because sometimes if you just want to close the door, for example, we've had to do that a lot because the broody chicken has to get locked out of the house pretty much every day, and we don't want to feed the chickens every time we close the door, which will happen, because again, the Arduino really isn't that smart. It can't tell the difference between a person closing the door versus light level closing the door. But what we're going to do is set it off for you and make my already slightly overweight chickens a little bit more overweight. So there's two buttons on the front of this thing. You have down arrow and up arrow, and they do exactly what you think they would. They close and open the door. So currently this is on the don't set off the feeder cycle, where there's the blue light on. I'm going to keep the camera pointed at the light, so I'm just going to close it, and then I'll show you the door closing. But what happens when I start closing? There. The light blinked. I'm going to put this on high gain again. So the light blinks. The door closes. And after 1 minute, this light will turn off, and nothing else will happen. So that means that the feeder will not go off. So the door is completely closed. And now we're just going to wait a little bit, and this light will turn off. Okay, light just turned off there. When the light's off, it means it's ready to go. So now when the door opens, this light will blink again, and then we will wait 45 seconds, and the chickens will be fed. So I'm going to point this over here again so you can see. Opening. Okay, light blinks. Door's opening. And now we're going to head over to the feeder because the rest happens at the feeder. Okay. There we are. I think this kind of overfeeds them too. I think I need to adjust the timing. But everyone's going to come running here in a minute because the feeder's going off. Chickens aren't that... Okay. That always scares me. But now they're excited. There's food. Life is good. So I guess the real question is, did this whole experiment work? Are the chickens quiet now? No, they're not. It feeds them. It lets them out in the morning. But these are very tame chickens, and they crave human attention. And I think pretty much the only way to get them to shut up is to come out here and give them the attention they think they deserve. So, until I can find a way to automate someone coming out here and petting the chickens, I think they're going to continue being very loud in the morning. But that's all I have today. Here's a little, supposed to be quick, but I always somehow make 20-minute videos. Look at what I do to automate my chickens, because this is a techie household and we can't have farming kept the way that it is supposed to, which is simple. So that's all I have for you today, so thanks for watching. I also need to plug my website. I have a website now. It's owens-tech.xyz. I'll put it on the screen here or something. And there's not much on it right now, but I'm gonna probably put things on there that don't really need their own videos. I don't know exactly what that'll mean yet, but just random things, and I'll probably also make a post every time I make a video too. I don't know, but go check it out. As always, check out my Minecraft server, links in the About page. If you play Minecraft, you can do that, and yeah, these are my chicken nuggets.